In the next session, previous session actually, we just see the in the basics of open loop, in the basics of the control system. Open loop control system. In the previous session, we finished the open loop control system. Now we will see in the comes under the category of basics of control system, closed loop control system. We will see this portion now, but which is very simple. Once if you understand this particular open loop control system definition, and automatically there itself actually I am giving the definition of both open loop and closed loop, so you can easily understand the closed loop control system definition also. Once if you understand this is nothing. But anyway, for better understanding, then what we are doing is, then we will take one simple example. Based on that example, we will try to construct the closed loop control system, block diagram, features, blocks and everything. Okay. So what is closed loop control system? This is closed loop control system. So then one simple example I am giving. Now we will take one simple example. The example as air conditioner. We are all familiar with the air conditioner operation and everything. Then I take that example and we will try to build up the block diagram, features, explanation, definitions and everything with a taking example of air conditioner. Then you tell me, while proper operating of the air conditioner, what is your role? What is your role while proper operating of the air conditioner? You are saying that, sir, I am spending a 50,000 rupees and I just purchase a new air conditioner. Okay. Then after that, you install the air conditioner. Okay. Then you give the supply. Okay. Then what is your role while proper operating of the air conditioner? Okay. All these tasks you are doing. Then after that, what is your final task? Then what you are doing is, you just take a remote. You just take a remote and you just set the temperature as air conditioner. Am I not? You just take a remote and you just some temperature you are setting in the remote of the air conditioner. Then there we will start, at that particular point we will start the operation of the air conditioner. Now see here. Now for example, you are taking, you just take a remote and you just set the temperature as 20 degrees centigrade. Now the question is, this is 20 degrees centigrade temperature. This is 20 degrees centigrade temperature. Then what is the meaning of that? Then if you take a remote and set the temperature as 20 degrees centigrade, now what is the meaning of that? With respect to your point of view, that 20 degrees centigrade temperature is your target, your aim, your goal. You are expecting that the room temperature should be 20 degrees centigrade temperature. For that purpose, you take a remote and set a temperature as 20 degrees centigrade, and you are expecting, with respect to your point of view, with respect to your all point of view, that 20 degrees centigrade is a desired output, is a goal, is a target. You are expecting that temperature should be presented in this particular room. Is it right or not? Yes. Now my question is, now how this 20 degrees centigrade temperature the machine will be considered? The machine will be considered this 20 degrees centigrade temperature as what? The machine will take this 20 degrees centigrade temperature as reference level. The machine will take this 20 degrees centigrade temperature as reference level, or let us say reference input. What the machine will take? The machine will take this 20 degrees centigrade temperature as reference level or a reference input. Therefore, your job is over. You just take a remote and set the temperature as 20 degrees centigrade and you just keep the remote aside and you go to bed. Then now the remaining portion is machine operation. Then what the machine will do? What the components the machine? What are the components in the machine? Then how it will work? That also we'll see under the category of this particular closed loop control system with the example of air conditioner. That's what I'm saying. This 20 degrees centigrade with respect to your point of view as a goal, target, expected value, desired level. Then, but the machine will take this 20 degrees centigrade temperature as a reference level or a reference input. Therefore, we are talking about control system now. We are talking about control system. Therefore, not only reference input, not only reference level, controller. Now, the question is, this is the air conditioner. Then once if you set the temperature as 20 degrees centigrade, then that air conditioner will have a sensor. Is it right or not? The air conditioner will have a temperature sensor. The air conditioner will sense the actual temperature of this particular room. What is the actual temperature of this particular room? First it will sense. Let us, for example, the actual temperature of this particular room is, let us say, some 30 degrees centigrade. Let us say the actual temperature of this particular room is 30 degree centigrade temperature. But what happened now? Here, the sensor is sensing that the temperature is 30 degrees centigrade. The sensor is sensing that the temperature is 30 degrees centigrade. But this is a control system. Therefore, there is a controller. There is a controller. This controller will apply some controlling actions. We already know that. This controller will apply some controlling actions. Let us say, for the first controlling action, the fan mode is on in the air conditioner. Let us say this is one of the example of the control system is nothing but controlling action. One controlling action is fan mode is on in the air conditioner. Once the fan mode is on in the air conditioner, now see here, this is controller producing the controlling action, and now the controller input is this 30 degrees centigrade. Is it right or not? Therefore, this 30 degrees centigrade is fully under the controlling actions produced by the controller. That's what we are saying. Now, this 30 degrees centigrade is fully under the controlling actions produced by the controller. One of the controlling actions is fan mode is on. Therefore, this 30 degrees centigrade is controlled and it will become some 26 degree centigrade. That's what we called previously. What is the controller output we are calling as previously? This is nothing but controlled input. What is this? This is controlled input. Now, this 30 degrees centigrade is fully under the controlling actions produced by the controller. Therefore, this is controlled input. Now 30 degrees centigrade is controlled by one controlling action and it will become 20 degrees centigrade. What is the after block? What is the block of after controller? What is the block? You know that. What is that? That is processor. That is processor. Now this 20 degrees centigrade temperature is further processed by a processor and it will become, for example, some 25 degree centigrade. Therefore, this is nothing but processed output. And some of you are thinking that, sir, in the open loop control system, whatever the processed output, that is the desired output. So here is also you are writing, now whatever the processed output, this is the desired output. This is wrong. That is 100% wrong. Why? That's what, first of all, I am asking, what is this 20 degrees centigrade? You are all saying, sir, this 20 degrees centigrade temperature is I am expecting in this particular room. This 20 degrees centigrade temperature is my desired output. This 20 degrees centigrade temperature is my expected value. This 20 degrees centigrade temperature is a desired output. But how much output you are getting here? Then here 25 degrees centigrade temperature, then how you can say this is the desired output? This is wrong. This is not the desired output. This is just a processed output in the case of closed loop control system. In the case of this processed output is called as desired output in the case of open loop control system. Therefore, this is not the desired output. This is just a processed output only. Now you tell me, this is a processed output. Then your job is completed, you go to bed. This is the job of the machine. Am I not? Sir, then my machine is working properly or not? The machine is spending 50,000 upon the machine. The machine is properly operating or not? Yes, the machine is continuously monitoring his performance. Like you are monitoring your performance now. Then how you are monitoring your performance? Then you write the examination. Then the results are came. A madam is distributing the papers. Sir is distributing the papers. Then you received your paper. Now out of 100, then you can get how many marks? Out of 100, you can get 10 marks. Then what you are doing, out of 100, you can get 10 marks. You immediately look your friend got 9 marks, then you are very happy. Why? Out of 100, you can get 10 marks, but out of 100, your close friend get 9 marks, but you are very happy because you are getting 1 mark more than your friend. Like that you are comparing your performance? Obviously, and your both results are failed. No, not like that. Your performance is not comparing like that. How to compare your performance? How to estimate your performance? Sir, I can get 10 marks. But the reference level for pass percentage for the reference level is 40 marks. But I can get how many marks? 10 marks. Reference level is how much? 40 marks. How much is the deviation? Oh, there is a large deviation of 30 marks. So that is error. You can easily estimate your performance. Your performance is good or not. In the same manner here is also, after doing some operation, after doing some machine operation, after doing some task, now this processed output is 25 degrees centigrade. This 25 degrees centigrade is compared with the reference level. Therefore, this processed output is compared with reference level. If you want to compare this processed output with the reference level, first this processed output is brings to the input side. Then whose job is that? Who will bring that processed output to the input side and compare with the reference input? That job is done by another block here. Then that is nothing but a feedback network. This is nothing but what we call as sensor. This is the feedback network. Now this feedback network will bring the processed output. It is continuously sensing 30 degrees, 25 degrees, 24 degrees like that. Then this is processed output. This is processed output. What is the job of the feedback network? The feedback network is the property of this closed loop control system. This is closed loop control system or not? We will see the definition. This feedback network is the property of this particular control system which brings a processed output. How much is the processed output now? What is the processed output? 25 degrees centigrade is the processed output. Now this 25 degrees centigrade is compared with reference level. What is the reference level? 20 degrees centigrade. What is the processed output? 25 degrees centigrade. Is there any deviation? Is there any differences? Yes. See here, this is nothing but comparator. This is a comparator. This is the comparator. One of the input to the comparator is a reference level, reference input, and another input to the comparator is a processed output. Now, the feedback network will bring the processed output and compare with a reference level. Then if you observe here, what is the processed output? 25 degrees centigrade. What is the reference level? 20 degrees centigrade. Is there any deviation? Is there any differences? Yes, there is a differences. Yes, there is a deviation. Then that deviation, that difference is nothing but error signal. This is the error signal. How much is the error? This is 25 degrees centigrade. This is 20 degrees centigrade. Then the deviation is 5 degrees centigrade. Therefore, that is nothing but error signal. Then what is the input to the controller? Now you tell me what is input to the controller? Controller input is error signal. When the controller input is error signal, controller is thinking that, oh, my boss is not satisfying. Now my performance is not good because I can get input as error signal of error how much? 5 degrees centigrade. The error signal, controller input is error signal, error is 5 degrees centigrade. My performance is not good. My boss is not satisfying. I want to work more properly. I want to work more effectively. Therefore, then controller will automatically, here I'm saying controller will automatically apply the second controlling action. This is compressor is on. This is also you observe in your air conditioner and refrigerator also. Now you just switch on the air conditioner and you just set the temperature. After sometimes you observe that then yes, the compressor is on now. After sometimes also you may observe that the compressor is automatically getting off. Once this one controlling action is working, fan is on, this controlling action is continuing, and now in addition to that then another controlling action which is nothing but compressor is on. These two controlling actions are simultaneously working on which particular value. That's what I'm saying. This is a feedback network. This is a sensor is continuously monitoring the actual temperature of the particular room. It is monitoring, first it will be 30 degrees centigrade. Now next it will be 25 degrees centigrade. Therefore, these two controlling actions is simultaneously working on this particular 25 degree centigrade, because now two controlling actions are simultaneously operating on this 25 degree centigrade, and therefore this is further processed and it will become 22 degree centigrade, because now two controlling actions are simultaneously operated on 25 degree centigrade, and this 25 degree centigrade is now after controlling, then this is 22 degree centigrade and it is further processed and it will become 20 degree centigrade. Now see here, now these two controlling actions are simultaneously operated on 25 degree centigrade and it will become 22 degree centigrade and further processed and it will become 20 degree centigrade. Therefore, then this is nothing but the desired output or not? This is nothing but this 20 degree centigrade is the desired output or not? No, this is just a processed output only. This is just a processed output only. Why this is processed output I am saying? Because here one network is available. Now this is a sensor. It is continuously sense the temperature. Now what is the temperature now? This processed output is nothing but 20 degree centigrade. Now this 20 degree centigrade is coming here. The feedback network will bring the processed output. What is the processed output? Now it is 20 degrees centigrade. Now this 20 degrees centigrade, compare with a reference level. Is there any deviation? The processed output is 20 degrees centigrade and reference level is 20 degrees centigrade. And how much is the deviation? 0. Now what is error? Error is 0. When error equal to 0, then only this processed output is called as, desired output. Then only this processed output is called as desired output. When error equal to 0, this processed output is called as desired output. Now you tell me what is the best name for this? When I am saying this is the desired output, when I am saying this is desired output, I am saying this processed output as a desired output when error equal to 0. When error equal to 0, then this processed output is nothing but a desired output, which means that can we call this is an accurate output? Yes. When error equal to 0 means it is more accurate. This is accurate output. When accuracy is more, and obviously it will become more stabilized output. This is stabilized output. When error equal to 0, therefore it is more accurate and more stabilized. When error equal to 0, that's why this is called as accurate output. This is the best name for this. And of course we are applying some controlling action, therefore which may be called as controlled output. This is controlled output. Now the question here is, now see here. Now first is 30 degrees centigrade. Then you observe here, first is 30 degrees centigrade and one controlling action is operated. Then see here, first is 30 degrees centigrade and one controlling action. Next output is 25 degrees centigrade, another controlling action. Now see here, you are saying that compressor is on. You are saying that compressor is off. No, we cannot say the compressor is on. We cannot say compressor is off. It is automatically done, which means that now here, sometimes fan is on, sometimes compressor is on. Now these are the controlling action is completely dependent on the output. This processed output is nothing but the output. Therefore, in which control system, see here, these are the controlling action. First only fan is on. First controlling action is only fan on. And second controlling action is compressor is on. After some time, compressor is off. Now how it will be operated? These controlling actions are completely depends upon this processed output or output, which means that these controlling actions are completely depends upon the output, which means that in which control system controlling actions are completely depends upon the output. In which control system controlling actions are depends upon the output, then that control system is said to be closed loop control system. Now see here, this is a closed loop control system where these controlling actions are completely depends upon the output. The controlling actions are completely depends upon the output, then that control system is called as closed loop control system. In the previous session, what we are doing is open loop control system where controlling actions are independent of the output, then that control system is called as open loop control system. If it is independent, this is open loop. If it is dependent, this is closed loop. Am I right or not? And one more thing, we cannot say compressor is on, compressor is off. No, this is automatically done. Am I not? Compressor is on off compressor, off of compressor. That is automatically done. Therefore, in closed loop control system, the controlling actions produced by the controller is fully automatic. Therefore, the second point is controlling actions produced by controller is automatic. The controlling action produced by controller is automatic. Therefore, this closed loop control systems are also called as automatic control systems. Therefore, where you just compare the previous one and this one. In open loop control system, where the controlling actions produced by the controller is manually operated one, therefore that is manual operated control system. But this is automatic one, therefore this is automatic control system. Why this is automatic? Means here it consisting of a sensor. Here it consisting of a sensor. Therefore, we already have a third point, which means that a control system which consisting of sensor comes under now 3 points in previously open loop control system I am saying the same 3 points and now in the closed loop control system I am saying. So your notes is also a comparison purpose. You can easily compare whatever we studied the previous topic and automatically you can understand the next topic, same points within a reverse manner. Okay, you can easily understand. Here controlling actions are completely dependent. In open loop control system, controlling actions are completely independent. Now here controlling actions are produced by a controller is fully automatic. There the controlling actions produced by the controller is manually operated one. Therefore that is manually operated control system and this is automatic control system. And a control system which consisting of a sensor is closed loop control system. A control system which does not consisting of a sensor is a open loop control system. And you just compare the open loop control system and closed loop control system. What is the extra block here? Controller is available in open loop. Here is also available. Processor is also available in open loop. Here is also available. Output is available. Input is also available. Then what is the extra block here? The extra block here is feedback network. This is the important one here. Because of this feedback network only, because of this sensor only, we have to generate this error signal. Based on this error signal, this fellow is working properly. Based on this error, then we can estimate the performance of the system. Therefore, then this is the feedback network which is very important. Is available in the closed loop control system. Therefore, this closed loop control systems are also called as feedback control systems. Therefore, this closed loop control systems are also called as feedback control system. Therefore, this closed loop control systems are also called as automatic control systems are also called as feedback control systems. Then this is a difference between open loop control system and closed loop control system. You can easily understand. Once if you understand the open loop control system, you can easily understand the closed loop control system. Then whatever the points I am saying in the open loop control system, same points I am saying in the closed loop control system, such that you can easily understand the differences. Not only that, and this is the block diagram of closed loop control system and previous one is the block diagram of open loop control system. We can easily understand. We'll take a small example as air conditioner. Take this as the block diagram and these important points you can note it down, because based on these two block diagrams we will move for further topic of this control system. Okay, first you copy this all this block diagram and the points and everything. Okay. So then you understand the importance of open loop control system, definition of open loop control system, closed loop control system, and what is the block diagram of open loop control system, what is the block diagram of closed loop control system. Yes, but we'll take two examples and we will finish what is open loop control system, what is a closed loop control system. Now my question is, it is not possible to bring all the systems into the class and what is the behavior. So we cannot see the compressor, what are the components in the air conditioner, and washing machine, what are the components in the air conditioner, fan, what are the components in the air conditioner. We cannot see that particular components are presented or not in the class. But in the class, what we want to do it? In the class, I want to understand the behavior of the air conditioner. In the class, I want to understand the behavior of the washing machine. In the class, I want to understand the behavior of the machine. In the class, I want to understand the machines. In the class, I want to understand all the control systems. Even if you are not able to see physically, you want to understand the behavior. That is possible once if you have a mathematical analysis, once if you have a mathematical relations, once you have a mathematical relations with you, once you have a mathematical analysis with you, you can easily understand the behavior of that particular control system. Therefore, now we go to the next topic. I want to see the behavior of any control system. I want to understand the complete behavior of any control system. Then what I want to say is, then you can understand the behavior of the control system. You can understand the complete behavior of the system once you have a mathematical relations are available with you. Therefore, what I want to say is, that complete behavior of the control system, that complete mathematical relations which is given to you by a mathematical tool which is called as transfer function analysis. Then what I'm saying, transfer function analysis. Why this topic comes into the picture here? Transfer function analysis. Now see here, this transfer function analysis, why this topic is coming to here, which means that's what I'm saying. So I want to see the complete mathematical equivalent model of a control system. Therefore, that is given by transfer function analysis, a complete mathematical equivalent, the complete mathematical equivalent model of a control system or a system is given by transfer function analysis. Once you have a complete mathematical equivalent model, then you can easily understand that particular control system or not. So based on this, once you have a complete mathematical equivalent model, we can understand the behavior of control system. Now these are the two important points, such that now this transfer function analysis which is useful here. Then what is the transfer function analysis? What is the purpose of that? Now based on the transfer function analysis, we can have a complete mathematical equivalent model, complete mathematical analysis of a control system. Once you have a complete mathematical equivalent model, then you can easily understand the behavior of the control system. Means even if you are not physically observed that particular machine, sir, this machine I never see physically, this machine I never see practically, but I want to understand the behavior of this machine. I want to understand the complete behavior of this particular machine. That is possible with the help of this transfer function analysis. Once you have a transfer function, then you have a mathematical equivalent model. Once you have a mathematical relations, then definitely we can understand the complete behavior of this particular subject. This is the advantages of the transfer function. That is the reason why we use the transfer function analysis here. So how it is useful? Now it is useful for me. I want to see the mathematical equivalent model of open loop control system or the mathematical equivalent model of closed loop control system. Now, based on that mathematical equivalent model, I can understand the complete behavior of the open loop control system, and I can understand the complete behavior of the closed loop control system. This is advantages of transfer function analysis, or importance of transfer function analysis. What is the advantage and what is the importance? Now, the question here is, sir, why transfer function analysis? I'm giving this to other advantages of the transfer function. So, if the transfer function analysis is giving this type of important advantages, this type of important points to us, what is there in the transfer function? What the transfer function consisting? What is the definition of transfer function? What the transfer function relates? What the transfer function is dealing? The transfer function is dealing with what parameter such that I can have this type of advantages, I can have this type of features, then what is the transfer function is available? Now my question is, then you go to a mobile shop. You want to purchase a mobile, then you go to the mobile shop. Then one mobile is looking good, one mobile is looking very slim and which is very good. Then you purchase a mobile. Like that you purchase a mobile. If mobile is appears to be good, then you purchase a mobile. No, not like that. Then you tell me how you purchase a mobile. Then you want to see the features of the mobile. You want to see the applications. You want to see the characteristics. You want to see the behavior. Based on all these particular features, then you came into a conclusion that yes, this mobile is having a number of features, number of applications, number of parameters. Then you are considering all these parameters and you want to decide that yes, I want to purchase this mobile. In the same manner, the transfer function is so important because what is there in the transfer function, first we want to be identified. Now first we want to see the definition of transfer function such that you can understand why the transfer function is important role is playing here. So this is the importance of the transfer function. You just take it down. Now the question is the definition. We will see what is the definition of transfer function. Now what is transfer function? Now see here, for a linear time invariant system, take down the definition. For a linear time invariant system, the transfer function is defined as, for a linear time invariant system, the transfer function is defined as Laplace transformation of output. Laplace transformation of output to the Laplace transformation of input. Laplace transformation of output to the Laplace transformation of input with all initial conditions are equal to 0. This is the transfer function definition. What is the definition of transfer function? For a linear time invariant system, once again I am saying, for a linear time invariant system, the transfer function is defined as Laplace transformation of output to the Laplace transformation of input with all initial conditions are equal to 0. Then if you observe in the transfer function, it is a relation between input to output. What we want more than that? For identify a control system is good or not based on its performance, based on its response. Then one simple example which we already finished, air conditioner. The air conditioner is good or not, then how you can judge? By looking its company? By looking just a physical appearance of that particular machine? No. Then one fan is having a 10 wings, 10 blades, then such that you can think that the fan is good? No, not like that. Then how you define, how you can identify that system is good, that system is working properly or not, based on its behavior, based on its response. Sir, this air conditioner worth of 50,000 is good, we cannot decide it like that. This air conditioner is working properly, it will produce a good response, his output is good, his behavior is good. Now it's producing a good behavior, good response, good characteristics, then only it is, you are saying yes sir, this is a good air conditioner. In the same manner, sir, the control system is good based on its response. Response is nothing but output. Response, in our subject these words are repeated. Response means output. Excitation means input. So a control system is good or not, we can decide it based on its response, based on its output by applying its inputs. by applying the excitation. Give some input and see the response. Based on the response, you want to see its behavior. You want to see the behavior. You want to see the complete mathematical analysis of the control system, which is given by transfer function. This transfer function, which is so important, which will play the important role because that is dealing with a relation between input to output. There is a relation between input to output. Therefore, then what we are doing is, now we want to see the mathematical equivalent model of the open loop control system and a closed loop control system. And once you have a mathematical equivalent model of the open loop control system and closed loop control system, and you can easily find the transfer function and you can easily understand the behavior of open loop control system and closed loop control system. Before that, this is Laplace transformation. Laplace transformation, a number of times we just studied in our subject. A number of times in different subjects and in the mathematics also, the same Laplace transformation here. What is the Laplace transformation? The Laplace transformation of f of t, which is equal to capital F of s. The Laplace transformation of f of t, which is equal to capital F of s, which is equal to integral minus infinity to infinity f of t e power minus st into dt. The Laplace transformation of f of t, which is equal to f of s integration minus infinity to plus infinity into f of t e power minus st. Now, what is s? You know that, you already know that. S, which is equal to sigma plus j omega. S, which is equal to sigma plus j omega. This is the real part. This is the imaginary part. This is the real part and this is the imaginary part. Then this is positive real part. This is negative real part. This is positive imaginary part. This is negative imaginary part. This is positive real axis, this is negative real axis, this is positive imaginary part, this is negative imaginary part, and this is the intersection point of real part and imaginary part. This is the real axis and this is the imaginary axis. Real part is 0, imaginary part is also 0. This is nothing but origin, which is the intersection point of real part and imaginary part, and this which we called as S-plane. This which we called as S-plane. Then what I want to say is, this is S-plane. Now our subject is slowly will shift totally into S-plane. Now we can study the total control system and within this S-plane, and we can easily understand the total behavior of the control system. Not only I'm talking about any single topic, the total control systems, what is there in the control system, now what is the behavior of the particular control system, you can easily understand and you can easily judge by looking this S-plane. What are the behavior of this S-plane, what happening in the S-plane, then you can easily understand very slowly. Therefore, that's what I'm saying. Then this is the S-plane where this is the real axis, positive real axis, negative real axis, positive imaginary axis, and negative imaginary axis. Then what I'm doing is, now this is the S-plane. This is S-plane. Now slowly I just converted our total subject behavior or analysis into S-plane. So see here, then what I'm doing is, this S-plane I am dividing into 3 parts. One is left hand side of, this is left hand side of S-plane, and this is right hand side of S-plane. This is left hand side of S-plane. This is right hand side of S-plane, and this is imaginary part of, this is left hand side of S-plane, this is right hand side of S-plane, and this is imaginary part of S-plane. So if you observe here, I am doing this S-plane, I am dividing this S-plane into 3 parts. One is left hand side of S-plane, right hand side of S-plane, another one is imaginary part of S-plane. So now the question is, sir, why you divided this S-plane into 3 parts? This is left hand side of S-plane, imaginary part of S-plane, right hand side of S-plane. that we can easily understand. That's what I'm saying. Now, something happening here. There is the importance of this left hand side of S plane. There is the importance of this right hand side of S plane. There is the importance of this imaginary part of S plane. That's what then. Once if you understand what is our subject, how the subject is behavior, and now what is the behavior of the subject in the left hand side of S plane, what is the behavior of the control system when it is in the right hand side of S plane, what is the behavior of the control system when it is on imaginary part of S plane, slowly we can understand. So this is a S plane which we are dividing into 3 parts. What is the importance of the first part, second part, third part? And now after understanding the importance, then you can have the differences of left hand side, right hand side, imaginary part. Now this is Laplace transformation, simple formula, and this is S plane, you already know that. And sir, why you come to the S plane? Why you have to come to the S plane? There are so many transformations here. Fourier transform, time domain to frequency domain. Fourier transform, time domain to frequency domain. Z transformation, discrete time domain to Z domain. Now, Laplace transformation, which we are using here, time domain to S domain. All these are the transformations which are changing from one domain to another domain. Is it right or not? All these are the transformations which are changing from one domain to another domain. Now, this is a time domain and this is frequency domain. This is a time domain and this is the frequency domain. Now these are the transformation is changing from one domain to another domain. Now Fourier transform, Z transform, Laplace transformation are changing from one domain to another domain. Therefore, sir, is there any advantages of this transformation? Why we are changing from one domain to another domain? Then why we are changing from one domain to another domain? There is an advantage. Definitely there is an advantage. Otherwise, we cannot go for one transformation to another transformation. All these transformations are changing from one domain to another domain. While we go for the transformations, we can get the advantage. That's what now I am also here. I'm choosing S plane. Now compare with the time domain to S domain, therefore definitely we can have some advantages. Sir, what type of advantages if you are gain? What is the advantages of this transformation? Yes, you have the advantages of the transformation. Now see the first advantage of the transformation is, the first advantage of the transformation is the mathematical analysis. Mathematical analysis is easy. The mathematical analysis is easy in frequency domain compared with time domain. We can see the complete behavior. We can see the complete behavior in frequency domain compared with time domain. And third important point, we already know that for calculating bandwidth. Now, these are the advantages of transformation. These are the advantages of transformation. First advantage is the mathematical analysis is easy. The mathematical analysis is easy in frequency domain compared with time domain. And we can see the complete nature, we can see the complete behavior in frequency domain compared to time domain. For calculating bandwidth, we want to go to the frequency domain. So these are the advantages of the transformations. That's why in our subject also we take one of the transformation, which is Laplace transformation, which is more convenient to our subject. Therefore, I can take the Laplace transformation and slowly we can complete the total behavior of the subject in the Laplace transformation in the S domain. Once if you transform time domain to frequency domain, and these are the advantages if you are gain. These are the advantages of one transformation to another transformation. So now you have some basics idea of the Laplace transformation and S domain and all these things. Then we straight over go for the mathematical equivalent model of open loop control system and mathematical equivalent model of closed loop control system. And from that mathematical equivalent model, then we can easily find the transfer function. And based on the transfer function, we can understand the complete behavior of the subject. Okay. Now first you take down, and next session we start with the transfer function of open loop, closed loop, and behavior of open loop and closed loop.